Dear all, I would like to thank you for joining this presentation on behalf of myself and my co-presenter, Lilit Kharatyan. And we also thank the organizers of the workshop for this great opportunity to share our research at SIGType 2026. In this talk, we would like to present a prototype of an online research tool designed for building Valency Lexica from treebanks stored in the conlu format and following the UD annotation scheme. I will start with a short introduction about the purpose of the app, and then Lilit will give more details on its architecture, interface, and possible future developments. The UD treebank database currently includes over 300 treebanks for some 180 languages, which makes it an important resource for typological linguists. As you may know, the UD formalism has many specific features which differ from traditional approaches to formal morphosyntax. For example, UD doesn't support the traditional distinction between arguments and adjuncts. It regards inflectional cases on a par with prepositional phrases as case marking and holds a nominal constituent of a prepositional phrase as its syntactic head. However, these features primarily serve to support cross-linguistic comparability of annotation, and we believe rather constitute a merit than a limitation. And therefore, we believe that open access tools that facilitate research-based studies on the UD treebanks may be of interest and helpful for the linguistic community. And so the tool which we present today belongs to this type of resources. The development of the app started with an implementation for the UD treebank of classical Armenian. First, we have developed the app for Armenian and then isolated the core treebank independent functionality to increase the reuse potential of the app. And the resultant codes can be reused for any validated UD treebank thanks to the highly standardized UD annotation, whereas treebank-specific extensions that we distribute together with the core app can also be applied, although with some necessary adjustments, only to a subset of UD treebanks that share those treebank-specific features with the classical Armenian treebank. The classical Armenian implementation of the app is available online under the link on the slide. So the most part of the functionalities that we present in our talk can also be tested online already at this point. Summarizing the functionality of the app, it automatically retrieves verb frames of all verbs in a treebank together with exhaustive lists of its occurrences. The search engine is provided with an online interface that supports queries based on a subset of syntactic relations of verbal dependencies that belong to a verb frame, as well as based on morphological features of those dependents and their lemmas. This functionality enables frequency-informed research on valency classes, on the encoding of arguments, alignment, valency alternations, and so on. One can quickly check whether a specific valency frame occurs in the corpus or whether a specific lexeme fulfills a syntactic role for a given verb in the corpus, or one can establish which encoding for a given type of argument is more frequent in the corpus. And moreover, the standardized UD annotation of the treebanks for which the app is designed allows to immediately put the obtained results into a comparative typological perspective. The Armenian implementation of the app has proven to be very helpful in assembling data for contributions to several typological projects. For example, it was instrumental for assembling datasets for the World Atlas of Transitivity Pairs and the Pavia Verbs database. Of course, there are a number of search tools that allow working with UD treebanks. However, they often come with technical requirements which may burden their usage by a wider circle of linguists. For instance, there are general purpose online search tools to retrieve data from the UD treebanks, such as PML, Tree Query, or Tundra. However, these work with formal query languages, and On the other hand, for instance, the UD Easy app designed to query convolute tree banks without knowing formal query languages require installation of the app and doesn't have an online interface. And in this regard, the app that we present is, to the best of our knowledge, unique in offering a user-friendly online interface tailored for the study of verb frames based on UD tree banks, which doesn't require knowledge of formal query languages. The codes of the app are in open access. You can find them on the GitHub following the link on the slide, which is also accessible via the QR code on the slide. And we encourage those who may be interested in creating a Valency Lexicon of their language within the same UD methodology and with similar functional scope. We encourage to reuse those codes. Lilit may have more to say about it, but running the codes for a new tree bank and deploying the app is not a time-consuming task. So, well, given on the condition that the tree bank complies with the UD annotation guidelines. And with that, I give word to Lilit, who will share with you further details on the app architecture and user interface.
Thank you, Petr. I hope everyone can hear me well. Let me briefly introduce the architecture of your device. So the system has three main components: the backend, the application layer, and the frontend. On the backend, we use MariaDB relational database, which is automatically populated from UD tree banks in conv format. This allows the data to be stored in a structured way and retrieved efficiently through indexed, parameterized SQL queries. The application layer is implemented in Python with Flask, and this is where the user selections are translated into database queries and where verb lists, occurrences, frame information are generated dynamically. Finally, the front-end is built with HTML, CSS, and JavaScript and provides a responsive search interface. So the overall pipeline, in short, is UD tree bank, database, query engine, and then filtered verb lists and frame visualizations. Next, in the next slide, shows how verb frames are represented in UDeval. The system stores a verb together with selected types of dependents. This includes nominal dependents such as subject, object, indirect object, and oblique, as well as nominal modifiers in nominalized constructions. It also includes clausal dependents such as clausal subjects and complements, and auxiliaries for analytic verb forms. An important design choice is that nominal dependents are stored together with their encoding, that is, with case and at positions, which follows the UD treatment of at positions as case markers rather than heads. So the representation remains fully grounded in UD annotation, but it is reorganized in a way that makes valency patterns directly searchable. Next, I'll speak about the search interface and interaction. The interface allows the user to search by combining several parameters. As also Petr mentioned earlier, the verb lemma, the syntactic relation of a dependent, its encoding, and the dependent lemma. This means the user can formulate both broad and highly specific searches. For example, one can search for all verbs taking a direct object, or narrow this down to objects with a particular case or lexical filler. The interaction model is incremental. The user first specifies one dependent and can then add or remove further dependents, each with its own parameters. This is important because verb frames are usually defined by combinations of arguments rather than by one relation alone. So instead of writing a technical corpus queries by hand, users can build searches interactively, and the system dynamically returns the relevant verbs or occurrences. The interface features in the next slide return both aggregated and corpus level results. First, it provides filtered lists of verbs with frequency count, which helps the user see how widespread a particular frame is in the corpus. These lists can be ordered by frequency or alphabetically. Second, it also returns filtered lists of occurrences, so the user can inspect the actual corpus evidence behind the pattern. Another important feature is broad-based visualization, as you can see on your screen, of the filtered verb frames in sentence context. Together with the mouse over glossing and sentence IDs, this makes the results easier to interpret and trace back to the actual source. So one of the main strengths of the interface is that it combines flexible frame definition with immediate empirical verification. Next, I'll speak about potential functional extensions. Some extensions are already implemented for the classical Armenian tree bank, but they are reusable for other UD tree banks we have tested ourselves, which have similar properties. So these include Latinized input and transliteration, which are especially used for languages with non-Latin scripts. Another extension is search by English semantic gloss, which adds a semantic entry point alongside morphosyntactic and lexical search. The interface can also display sentence translations linked to external lexicographic resources, restrict searches to subcorpora, and filter by verbal morphological features. Taken together, these extensions show that UDVAL is not just a fixed tool, but a flexible framework that can be adapted to the properties of particular languages, tree banks, and research questions. To conclude, let me briefly mention the main limitations and future directions in the next slide. At the moment, some extensions still require manual adaptation, and the system is mainly focused on verbal heads and a restricted set of dependents. It also does not yet provide a unified interface for cross-tree bank comparison, which would be especially useful for typological work. On the technical side, response time increases with larger corpora, and the quality of the output depends on the quality of the underlying UD tree bank annotation. So the main directions for future work are clear. It's more automatic detection of treebank-specific features, broader predicate coverage, support for multi-tree bank comparison, and improved scalability. Overall, UDVAL already functions as a practical prototype for turning UD tree banks into searchable Valency Lexica. This was all. Thank you.